up to 600 volts.
Motor repair, take one. These 4 bolts here.
That shaft moves this lever.
It's alive! All right, it is here. It's a Challenger 1 long wing. Originally designed as an ultralight. This one has the 503 Rotax on it, which is a 2-stroke. I think it puts out about like 54 horsepower, somewhere around there. Yeah, well, it's not an ultralight with that motor on. It's supposed to have a 277 if I remember right. But yeah, it's here. So put one wing up there for right now. Gonna work on this one first. Definitely a barn find. This wasn't a do a few things and get it running type situation. This is a complete teardown. And actually I will be doing that. I'll be tearing it down to where it was as a kit and then building it back up. So all the coverings coming off. I'm gonna definitely put it on a diet. A lot of the I'm gonna take off the windscreen, the doors, not gonna put that on. Obviously I'll go into electric, but I'm going to keep the 503 because I might use that for a hybrid, which is going to be a later project. This is the first step. I've got the HT back there, actually an elevator. I'm going to pull all of this off, just strip it down, do a full inspection on it. Some of it's, you know, factory drilling, riveting looks fine, and then there's other stuff where, you know, well, not so fine. So I'm gonna put my DER hat on and as it were, and look over everything. Obviously this has been in a barn for a very long time, and well, rest in peace, buddy. But anyway, it looks like a POS because, well, it is a POS, but you know what, it's my POS. And I'm gonna strip it down and turn to something better. All right, so there it is. The surprise is unveiled. My next electric vehicle conversion video is going to be about me converting a Challenger 1 ultralight into an all-electric aircraft. This is a project that I've been wanting to build for probably around a decade now. Part of the reason that got me interested in electric vehicles to begin with, I was my full-time job is designing airplanes, and I wanted to build an electric one. But especially 10 years ago, the technology was very out of reach for the average person. When I did my first conversion back in 2009, I did lead-acid batteries. Don't need to tell you that lead-acid batteries don't make a electric airplane. But so I've done the past 5 conversions with the idea of building up to the point where I can have the confidence that I'm going to build an electric airplane and not catch on fire or crash or otherwise have regrets. So if you notice from my for people that are new to the video, new to the channel, feel free to subscribe. I'm going to be doing realistically probably about a dozen videos from this on this project. I'm also trying to for the people that have been watching, you know, previous videos of me just rambling along with the camera, and I'm going to try to add a little bit more polish so it's a little bit more enjoyable for those at home. A bit of background on me: I actually do aircraft design for a living, and I used to be a structures DER. I've spent a lot of time doing aluminum space frame structures. I'm a PE as well. That all being said, videos are just for people's education and entertainment, realistically. Just because you see me doing something on video doesn't mean that I endorse or condone that. So, you know, all the caveats there. There'll be a whole bunch of dry calculations and design work that won't be shown in the videos in the background. You're just gonna have to trust that I'm am doing those calculations and that I know what I'm talking about. But standard caveat, don't try this at home. So that being said, I'm going to take the Challenger 1 Ultralight and I'm going to be converting that into all electric. That isn't the end goal here. My end goal is actually doing an electric seaplane. That's what I really want to build. I'm not going to jump straight to that for various reasons. One is building my own plane and doing electric conversion all together is just adding a lot of elements of risk that just doesn't make sense. The second was I was able to buy this entire Challenger 1 with the wings that I really wanted and a Rotax 503 that I'll use for a later hybrid conversion. And I was able to get that for $3,000. So getting all the parts, I bought the airplane as parts, and honestly a lot of it's only good for parts. I'll do an entire video, I've already shot all of it, of the teardown, showing all the nitty-gritty bad things. Even if you're not interested in electric video conversion, I think a lot of Challenger owners are just other people that are interested in kit planes or buying used kit planes will find it interesting, because having a fabric cover airplane, there's a lot of things that can be hidden inside there, and I'll do a whole video on that. I'm also I'll do a whole video on the teardown. I'm also going to do build up my own batteries. I'm using 2 Tesla modules. They're 24 volts. Going to put them in series to make them 48 volts. So I'll do a whole video build up on that. And then I've also built a test bench over there. Seen some of the very limited videos of that years ago, me testing motors, and I'm going to be doing more of that. Have the IR camera on there. Testing different ESCs. I'm going to be using a brushless permanent magnet DC motor. Departure from the brushed DC motors that you guys see me build in the race truck. It's also going to be very different power levels we're talking about. I'm going to be testing motors like this one here. This is around 2 horsepower, and which is a big departure from the 800 horsepower that I'm building in the race trucks and the videos that you've seen I built for those motors. So I'll be doing a lot of testing on that, and I'm going to do a full video on that. And then just fixing the aircraft, all the things that are wrong on it. Do all of that stuff before I even think about actually building this into or actually start work on building it into an EV. And then there'll be lots of fun, I hope, on testing as well. So why am I doing this? You know, first thing when you want to start a project is, like I said, so you want to build an EV is define what you actually want to get out of the project. If you haven't watched that video, definitely go recommend it. If people are thinking about doing their own conversion, try to cover the basics there. But for me, again, this is a mission that I've had in mind for a very long time. I want it to be a low and slow airplane. Very big difference from the supersonic planes that I design normally. It's literally the opposite end of the spectrum there. But so I want it to be low, slow, and I want it to be quiet. And again, it's all about the experience. This is not going to be a cross-country aircraft that you're going to be able to fly for 2 hours and go around the country. Battery technology really isn't ready for that. And so I actually won't be doing a ton of flying with this plane. Really, it's just I'm building this Challenger 1 as just purely for flight test. I'm an engineer, so I want data. I want to work out all the kinks and figure out the flying qualities before I then move on to the next phase. So let me talk about what I really want to build, and that is actually an electric seaplane, an ultralight float plane, something like that. So that would be straight. There we go. Ultralight float plane. It's not the first time that this has been built. I can't remember the gentleman's name. It's up in the New England area. Converted a Laser, if I remember right, to a twin motor powered by lipos. And that was quite a while ago. I want to say that was 2010, 2012, somewhere around there. And you know, had good luck with it. I've always had a soft spot for seaplanes. I've designed jets. I've designed prop planes. I haven't ever worked on a seaplane. So again, for me, these builds are about doing something fun, but it's literally the build process and that the actual, not necessarily the ends, but the means to get there. So yeah, I want to do a single float plane, parasol wing, and the big thing is I want distributed electric propulsion. That's one of the big things that I want to test here, and why I want to go through that with a known airframe. The Challenger 1, I think there's something like 1,300 of them have been built. They're a known aircraft. They have a few quirks, but you know, definitely have much lower risk than me trying to design and build my own airframe. Not to mention time. I've done a scratch-built fuselage before, and it takes a while. Once you start adding a lot of things together, the project can seem daunting, and that's where a lot of projects just end up dying. So anyway, back to that. So I want to do a float plane design, conventional tail, distributed electric propulsion. So that, for those not familiar, distributed electric propulsion, again, not a new idea. So we have a series of motors and propellers along the span of the wing. You do this for a couple reasons. One, it's actually very easy to integrate into non-conventional designs. By having the motors out all on the wing, you don't need to have a space for it on the fuselage. So, you know, traditional tractor configuration, you'll have an engine and propeller up front, or in a case of an electric conversion, you'd have a motor and a propeller out front. The Challenger 1 is actually a pusher, so it has a unique airframe design specifically to give you a place to put that. By going to this method, it gives a aircraft designer a lot of freedom on where you can put it. That's also one of the nice things about electrics, is that you're not dictated. You know, when you start designing a piston engine aircraft, for instance, or a jet engine, you'll figure out where the location of the motor is going to be, and you start working from there, because that is by far the single heaviest item on the aircraft, and it really drives the design from a weight and balance standpoint. Electric motors, these motors are very, very, very light. Again, this is a 2 horsepower motor. I'm going to be running about 12 of these. Really, for an ultralight, I can only have a certain amount of power, at least for the way it's written. So for those who aren't familiar with the ultralight regulations, this will be a Part 103 aircraft. It limits me to both empty weight and power off stall speed and maximum cruise speed. I'm going to say the numbers, but I'm probably saying them wrong. If I remember right, it's 29 knots for power off stall and 55 knots for maximum cruise speed. Don't quote me on those. Look up the FAR regulations. The empty weight has to be less than 254 pounds. That's without fuel. And without pilot. It only can have one pilot on board, no passengers. So that's that and a few other things are the requirements that you need for operating as an ultralight. Ultralight gives you a lot of things that you don't have to. I don't have to register it and number it. I don't have to meet some of the operational requirements. This won't have a 30-minute range, for instance. Probably looking at about a 20-minute endurance. Standard Part 23 aircraft, you have to have 30 minutes of reserve fuel on board, so I would never be able to take off if I operated it as a pure electric single-engine land aircraft. If you register as a motor glider, there's ways around that, but that's not what I'm looking at right now. So doing electric propulsion for a lot of those reasons. The other big one, and it's probably the biggest one, is that you are blowing air over the wing. So wing makes lift by air going across it. The wing doesn't know whether it's being drugged through the air or you're blowing the air over it. It's, think of a wind tunnel. In this case, by mounting all of the propellers along the length of the wing, it's called a blown wing. You're blowing air over it, so you can make significant amounts of lift at 0 airspeed. Now, I'm not trying to do a crazy vertical takeoff, quadcopter, etc. This is going to be simple fixed wing configuration, and but by doing this, it gives me very short takeoff and landing performance. Now, the Challenger 1 is no slouch. I think with the 503, if I remember right, it's like a 350-foot takeoff roll. That depends on who you're talking to, and those are numbers from the internet, so take them as what they were. But should be able to get significantly lower than that with the blown wing. Again, this is not a new concept. NASA's been doing it quite a while, working on their Spectre Actually, now they call it the Maxwell. They're going a different route. They're going to a very small wing, because when you do a blown wing, when it's powered, it gives you a very high lift, coefficient of lift. You can get CLs in the 6 to 8 range, depending on power and other installed factors, which is a very, very big improvement. The problem with going to a smaller wing is that you reduce your cruise drag. The wing gets small; it's hard to fit things in. But the biggest thing is if you have a power out situation, then you don't have that blown condition anymore, and so then you have a higher landing speed. Here again is ultralight going. I want it to be safe. I'm going to be flying it. So if there is a power issue, again, the power off stall, I have to have a power out stall that's in the 20 knot range. So that makes it, if I do have some sort of propulsion related problem, it makes it a much safer event, because obviously I'll be doing this in an open, unpopulated area. I can just land if need be. Obviously, do everything I can to make sure that event doesn't occur. The nice thing about using these are actually made for agricultural drones. These aren't RC airplane motors, though some people do use them for that purpose. The nice thing about it is that these are made in high volume, so the price comes down significantly. I think these are on the order of about $100 for 2 horsepower. So that means for the 20 horsepower that I want, I'm looking at about $1,000. You need to add propeller and ESC, but that would apply regardless of it. So I looked at other options for doing like just 2, 4, or just a single motor, and just didn't work out for various reasons. So I'm going to be testing these motors, as well as a whole host of other ones in a previous video. But assuming that all that works out, I'll have anywhere between 10 and 14 of these motors distributed across the wing. Also, I'm span loading that weight on the wing, which takes some of the bending moment off. Again, these are pretty light, so it's not a huge factor. But so anyway, I want to build an ultralight seaplane, but why do I have the Challenger? Well, one, I really bought the thing because I wanted the wings and I wanted the engine and propeller for a later hybrid project. I bought it for the cost of parts, and honestly, what I got is pretty much worth those parts. It has been crashed and repaired and crashed and repaired again, and probably crashed at least another time in there. There are bent landing gear, bent struts, buckled tubes, dimple tubes. There's a whole host of problems there. I'm still on the fence about whether or not I'll fix up that fuselage because it has so many things wrong with it. But again, I'll get into all that in a whole nother video. But so I got this Challenger 1. Why I'm using this later on, I'm going to be building my own fuselage composites, moldless composite construction. But there's a couple issues with that. One is I don't want to be doing initial flight testing off of water if I can avoid it. That literally adds a whole nother element that it wouldn't be good to do for such a unknown aircraft. The other is a practical standpoint. Colorado is the only state in the union that you cannot land or take off or operate a seaplane off of public lakes. Every other state you can. Colorado, it's not a law. Someone just made up a rule, I guess, back in the 70s or 80s, and it has been with us ever since. So that there's a couple of private places I could do it, but it very limits me being able to operate. And then the aforementioned, really I want to just be able to do the flight testing with a known aircraft. Really here I'm testing the electric propulsion system. Then once I'm confident with that, I will take out the Challenger fuselage, build up this, and I'll have my final end product. But that's not what I have now. So what I have now is going to be a Challenger. So if we switch this guy over to a Challenger, we got some tubes. Let's see. Normally there's a gas, the Rotax motor is back here, and it's actually not too different of a shape. Somewhere around that. Any Challenger owners, I apologize for my drawing, but and then there's braces and stuff in there. For those unaware, pilot sits up here. So again, I'm trying to get this experience of flying. So I am up front here. I don't. The wing's a bit over my head, but there's nothing else out in front of me. If I were doing a conventional tractor configuration, everything would be built such that I'd have a firewall and a big motor right in front of me. I didn't want that. That's part of the reason for choosing the Challenger. The other thing is that it's a very light construction. The bare fuselage with the tail on it, landing gear, pretty much everything but the power plant is about 100 pounds. I mean, I'll show you in the other video, I can pick it up just fine. And so keeping that weight down to meet that 254 pound empty weight is definitely a crucial part of it. So I've already removed the Rotax. Obviously if I do that, then my weight and balance goes all wonky. So I actually am going to put my two Tesla battery modules there. They weigh 55 pounds each. The Rotax with the motor weighs about, with a prop, weighs about 115 pounds each. Two 55-pound batteries replacing a 115-pound motor works out pretty much perfect, especially once I add the battery box and the mounting, etc. there. So that's going to mount right where the motor did. Keeps my weight and balance. I've already got structure to tie to there. It works out very well for that standpoint. And then the motors and propellers will mount up on the forward spar, and that's not quite ideal. I prefer the wing to either be in front of me or behind me so that I'm not in the propeller arc, but I'm going to do some things hopefully to mitigate risk on there. I'm not really worried about a blade out on an RC airplane motor, but doesn't mean I won't consider it. So anyway, that's going to be the general configuration. But first thing I do have to do is fix the airplane. So the one landing gear is the way it's supposed to be. It looks that way, and then the other one is something like this. This is a common problem for the Challenger. It's common enough that the factory actually sells a kit where you cut out the section of damaged tube, has a set of sleeves that you can put in and then replace all the broken parts. It's kind of characterizes kind of the weak link of the airplane. Part of the problem was that this was a Challenger 1 Ultralight, but they were running with a Rotax 503. They were probably operating it over gross. They were certainly operating it outside the Part 103 guidelines. This plane was never N registered. So anyway, I've stripped it all down, probably even beyond what the factory way this kit comes from the factory, because I'm going to have to replace a whole bunch of tubes and do a lot of rework on that. But so that'll be my first step, and that'll be the next video. That or maybe some motor testing. We'll see. But I'll go through the whole teardown and show all of the let's just say battle scars that this plane has come from. Again, you know, the plane really is. If it was a practical, you're going to keep it and fly it for 20 years, you would probably just recycle this fuselage. But I think I can be able to fix it to meet my mission, and we'll go from there. Stay tuned. So I wanted to double check the center of gravity. I did scales on each wheel, but especially with a configuration like this, as light as it is, I just put a chain hoist at the CG. You can see where the CG is marked there. This is with the tail, the vertical tail, and the rudder on. All the flight controls, as you can see, are still in. But wheels, tires, brakes, rudders, seat belts. These are pretty beefy seat belts here. Seat belts are significantly stronger than what it's attached to. But if anyone's wondering, that comes out to 103 pounds. And the center of gravity is right there. So pilot sits up here to balance that out. The gas motor, that Rotax, normally hangs right here. And the Challenger 1 Ultralight, which is what this is, supposed to come with a Rotax 277, if I remember correctly. So that's going to be significantly lighter than the Rotax 503, which you can see right here. But anyway, so regardless, I don't know what the weight of the small Rotax is for the Ultralight, but it is run with the 503, and but I'll do the whole weight and balance. But either way, I'm going to want the batteries right about here to balance out the pilot up front. Especially, I'm not a light individual, so it's pretty much going to be right here. And this is the batteries, or one of them, that I'll be using. It is from a Tesla Model S. This is a newer one. I think it's from a 2017 or 2018. It's actually a 5.4 kilowatt hour. I'll do a whole video on testing this pack, making the factory BMS work, as well as building a battery box. But like I said, I'll do a whole video just on that. This does Tesla does use limited liquid cooling, which is just fine for the size of pack that it has, but I will be reusing that liquid cooling loop because I will be operating these batteries near their continuous rating, so I'm going to need to give that residual heat someplace to go.